All right, so we are going to construct congruent triangles. Have I taught you section 4.4 yet? No. However, prior to doing section 4.4, which will be next week, we are going to construct congruent triangles 3 different ways. And I have written out for you the exact details of how to find them. They come from page 205 in your textbook. And we're going to answer questions 1 through 8. So you don't need your textbook because I wrote them all here. There's one correction that needs to be made, and we'll make that in a minute. So the very first activity that we're going to do is construct a triangle in which 3 sides are congruent to the other 3 sides of both triangles. We lovingly will call this side, side, side. If you can prove that 3 sides of one triangle are exactly the same measure as 3 sides of another triangle, they will both have the same interior angle measurements. So there's a theorem behind that, and we will study that next week. But for right now, we're going to do the construction. So very first thing says, select point D on line L. So we're going to go all the way down, so we have to move this up. All right, so we're going to select, you just put point D somewhere on the left of line L. So check this off, we did this. Then we are going to construct today mostly congruent line segments and congruent angles. So we're going to review that. So some of you had some issues on your quiz regarding that, so pay close attention. So yes, part of them. So I'll get to that in a minute. Construct segment DE. So we have to find the length to E such that DE is congruent to not AC, but this should read AB. So please change this to AB. That's the one correction, that's AB. Because aren't these in the corresponding places, AB and what's going to be DE? So to do a congruent line segment, you're going to take your compass and you're going to place the pointy end or the brad at A and hold your finger down there. Then you're going to find the hole on your compass here, or if you've got the pointy compasses, make this the distance between your pointy part and your pencil. Aren't those nice, big technical words? All right, so which would be a better? Oh, there we go. So there's a better choice, right? So keep your pencil in the hole, and then carry it and move your brad to D. Make sure your brad is on D or your pointy part is on D. And then you're going to draw an arc. Shouldn't those be congruent segments? That's all there is. All it involves is one arc. So there's line segment DE. It should be the same measurement as AB. So let's go ahead and measure it. We're going to measure it with the centimeters on here. So if I measure, isn't this just nearly, move it over, is nearly exactly 7 centimeters? So can we agree it's close enough to 7 centimeters? So let's measure this. Isn't that also nearly exactly 7 centimeters? So we have one pair of corresponding sides that are now congruent. There's one piece to our congruent triangle. So check this off, we did this. Then the next one says, using D as the center, draw an arc with radius the length of AC. So we have to measure AC. I'm going to take this measurement with D as our endpoint, and we're going to make an arc here. All we're doing is measuring another line segment. So we're going to measure with our compass from A to C. So put your brad at A, or your pointy part. Find the hole that goes through that. Your point C, which for me is right here. Keep your pencil in the hole. Move your brad to D. If I'm in your way, probably just move. Sorry. There's lots of other students. All right, then you're going to make an arc. Make a significantly large arc because we've got to draw a line somewhere up here because we're going to create this equal angle. Now, So we did this, right, using D as a center, draw an arc with radius AC. So check there. Now it says using E as the center, so we're going to go from the other side. We're going to draw an arc with radius of BC. So let's find radius of BC. So put your brad at B. And then find the hole that best matches up with C, so that looks good to me. I put my pencil in that hole, right? So for me that's, or your pointy part, open it up, make sure it goes from here to here. Then you're going to take your compass, if I can pick it up. You're going to take it down here to E and put the brad at E. Right? Put your finger at E and make that arc till it intersects with the other arc. X marks the spot right here. So we made our other arc. Then it says let F be the point of intersection of the two arcs. Here's point F. Check. Do I need to slow down? Huh? Do you want, okay. Do you want to borrow one? Okay. You pass that back down. Yes. Because you're not going to be allowed to actually have a ruler. I mean, okay. He wants to know, why can't I just measure from A to B here? Okay, you could. But then you're going to be an issue here and here. So you're still going to have to know how to find a congruent segment, because you can only measure from here to here. The only way to get this angle A correct is by taking this segment, measuring it with your compass, and then making an arc here. Doing the same thing for this segment, measuring that, and from here making an arc here, so that you know where the two lines, the two other sides of this triangle intersect. You cannot do that with a ruler. Josh. You could do that on one side, but you can't do it on the other two sides. And so then you're going to draw and connect from D to F, and then from F to E. Y'all done? So here's this. Thank you. And then I'll take that. Okay. Now, let's prove that these are congruent triangles. So we measured from D to E. Let's measure from D to F in centimeters. So if I measure from here to here, don't I have pretty close to 5 centimeters, right? Oh, wait, maybe I'm going to smidge you off. So hard to see in the dark. Oh, that is 5 centimeters right there. So 5 centimeters. And then I'm going to measure from A to C. And I also get 5 centimeters. So far so good. This is easy, if you know what you're doing, right? And then measure from F to E. And that is shy of 4 centimeters. So I'm going to call it 3.8. Because it's on the 8th line from 3, the 8th little millimeter. So this is 3.8 centimeters. And then this one, from C to B, also appears to be around 3.8. So we've measured all 6 sides of both triangles, just to prove something. We already did this one. The last question says, how does triangle DEF compare to triangle ABC? So what they're trying to get to is the fact that these look exactly the same, don't they? If we were to measure the angle at D and compare it to A, they would be the same. In fact, I'll do this once for you. But measure this angle. Doesn't it measure about 32, right? 32 degrees, give or take? And then measure this angle. If I extend this out, well, let's do it with my ruler so you can actually see. If I extend this out, isn't that also at, well, it's about 31. Am I close enough? I'm off a degree. That's close enough, right? So these angles are the same. If we did the same for E and B, they would be the same. And if we did the same for C and F, they would be the same. So our conclusion is that triangle DEF is congruent to triangle D and A correspond, and E and B do correspond, and so C corresponds to F. And what you're going to find out is we just did it by SSS. And I will explain next week what exactly SSS is. But we found the side lengths, all three sides on both triangles were congruent. So we cut down proving all 6 corresponding parts congruent to just 3. Didn't I prove it here by showing you the triangles? We constructed it with just side lengths. All right, so now flip it. What if we're not constructing just side lengths, that we're constructing side lengths and some angles? So I have up here on our triangle ABC, same triangle. In any triangle, up here on the left, the angle formed by 2 given sides is called the blank. So here's your 2 given sides. Don't those sides create an angle? Isn't the angle this one right here? Would you agree? Okay, so in any triangle, the angle formed by 2 given sides is called the included angle. It is included in between the 2 sides. C is not the included angle to those 2 sides. C is the included angle to what 2 sides? What 2 sides create C? CB and AC, right? So all triangles have 3 included angles because there's 3 vertices. So then answer these questions here. What is the included angle between BC? So here's BC and BA. So BC and BA. What's the angle that's formed? Angle what? B. And notice that they both have B in common, don't they? So what angle is formed by these 2? Angle C. If you look at CA and look at CB, isn't C the angle created? But it's easy to see without looking at the picture. They have B in common. Those 2 have C in common. Okay? All right, so this time we're going to construct a triangle in which 2 sides are congruent to 2 other sides. So we're going to take 2 sides on this triangle and create 2 congruent sides down here. And the included angle is congruent to the included angle on the other triangle. This is known as, notice how here we have side and then angle and then side. This is known as SAS. The angle is in between the 2 sides that create it. There's a difference between SAS and SSA, which would be a bad word spelled backwards. We don't use a bad word spelled backwards in geometry class, as you'll learn next week. All right, so how are we going to construct this? Select point G on line M. So I'm going to get everything up here, see if I can get it all in the screen at once. Okay, so select point G here, somewhere to the left, because point G is going to correspond to point A. So check that. Did it. Construct segment GH on line M such that GH here is congruent to AB. So we did that on the last one, right? Aaron, you're working with me. So same thing that we did on the last one. Put your brad or your pointy part at A. Find the distance from A to C, either with from A to B, either with a proper hole or open your compass. Right, so here we are. I'm going to bring my brad down to point G. I'm going to put my brad on G. And I'm going to create an arc. And this point right here is going to be point H. All I did was construct the side. So there's check 1. This is our S, by the way. We did the side. Then from that side, we're going to construct the included angle. So we're going to do S and then A, then S. So construct an angle congruent to angle A using GH as the side of the angle and point G as the vertex. So we're going to start here. This is one side. We're going to open it up here. So G should correspond to A. So we're going to create a congruent angle. So some of us had issues with this last week, right? So here we go. So I'm going to use a different color. We're going to go up here to this triangle. Put your brad on A. Anybody remember the first step? Nope. What's the first step? Find any measurement that you want and create an arc. But know what measurement that was. So I'm going to create an arc from both sides that create angle A. So I'm going to choose my arc to be O from here. So I'm going to go from here to here. But remember that distance that you chose. Everybody can have a different distance. Then you're going to take that distance and bring this back down to G. And you're going to create an arc here as well. So I have two of the same arcs. I'm going to put a point right here where this arc intersects line segment GH. Are you doing this, Josh, with me? Doesn't look like it. Now, in order to figure out where my angle has to open up here, because I have to have a point somewhere on this arc, I need to know how far on the arc to put that point. Can't I measure this arc right here with my compass? So if I were you, I would put nice points, not too big, but nice points right here so that you can read them with your compass. So I'm going to take my brad and put it on one of the points. And because this triangle is small, you're going to have to use the inner white circle here to find a hole that goes onto the next hole here. So you have to find the brad goes from here to one of these holes. So I'm going to choose this hole here. Keep your pencil in there so that you know that that's the measurement of the distance from this side of the angle to that side of the angle. Bring this, you have to swing it a little bit. Bring this down to the point that you put here. So your brad or your pointy part goes here. My pencil is still in the hole. I don't want to hold on to this because I won't be able to move the white part. So I need to kind of hold on to the ends of this right here so the brad doesn't move. And then I'm going to create an arc right there. X marks the spot. So that's telling me the distance from here to here on this angle. And so if I measured from here to here with my brad, I'm just going to double check to make sure that X marks the spot is the correct length. If I measure from here to here, sure enough, they are the same distance, so I'm going to go ahead and connect. I don't know how far to draw my line. I'm going to draw it as far as I can because I don't know how long my side is going to be. Connect it from here to here. So just put it right. We're going to do the same, well, we'll get to that in a minute. So this we just constructed right here. This was a congruent angle. So we just did SA. Now I have to measure this distance here and create a congruent side that is corresponding and congruent to AC. Isn't that easy to do with our compass? We're going to find the length of AC with our compass. So, use my red again. So find AC, we're going to construct GI on the new side of the angle such that GI is congruent to AC. So GI is congruent to AC. So put your compass or your brad at A. And then find a hole that approximates where C is. So I'm going to choose that one. Bring your compass all the way down to G. And put the brad or your pointy part on G. And make an arc. Doesn't X mark the spot? Here. And then because we're constructing GI, this is going to be labeled as I. So now we have created a side, a congruent side. So this is S. We have completed SAS. Watch how we're going to get a congruent triangle. All that's left is to draw H to I, right? So connect I to H. Done. Now it says, how does angle GHI compare to angle ABC? We can measure the angle here and the two sides here. Visually they're the same, aren't they? Right? So let's go ahead and measure our angle on our side. You don't have a protractor, but you'll have to trust me. So I'm going to measure GH, because that's one of the sides we created. Would you agree that that's 7 centimeters? Give or take. So let's measure this. This is also, give or take, a millimeter, 7 centimeters. Then let's take our protractor and measure this, angle A. Angle A, if I extend this, would you agree that it's about 30 degrees, right? So let's measure this. All right, this is 29 degrees, this will make a difference. 29 degrees. I believe I'm a degree off. Is that okay? And then this, no, yes it is okay. And then this one is 28. I'm going to go with 28. Are we close enough for government work? I'm okay with 2 degrees. That's entirely possible. But I'm off a degree, but as far as I'm concerned, we're close enough. Okay? But if you're off 5 degrees, no, we're not close enough. No. 2 is what we're going to go for. 2 is the limit. 1 is what you're shooting for, between no degrees off and 1. So we've got side, we've got angle. Let's measure our last side. Josh, you are not putting your head down. All right, so this side, would you agree is 5 centimeters? And then this side is also close enough to 5 centimeters. So we have proven our angles are congruent by side, angle, side. We get exactly the same triangles. So how do the triangles compare? They are congruent. Triangle GHI is congruent to triangle ABC, and they are congruent by SAS, which we will learn more about SAS next week, girls. Stop. We got one more to do. Are you ready? So third and last construction. The side of a triangle that forms a side of 2 of its angles is called, so here's what we're looking at. Bless you. We're looking at this side right here. Arms are not crossed, we're taking notes. Put the backpack down. And we're looking at this angle here. Don't these angles border the side? Aren't they the angles on either side of the side? If I'm looking at side AB, aren't the angles that border it the endpoints angle A and angle B? Isn't the side in between these 2 angles? So just like the angle on the last one was in between the 2 sides, and that was called an included angle, this is in between the 2 angles, so it's called an included side. So that's what you're going to write, included side. Josh, you're right now. You're totally not engaging in the lesson. Then over here, I want you to tell me, what is the included side between angle A and C? Angle A and angle C. What is the side that is in between them? AC. Do you notice that angle A and angle C give you AC? Bottom segment AC. So without even looking at the picture, what's the side in between angle C. Line segment BC. All right, so we are going to construct a triangle in which two angles are congruent to two angles of the other triangle and the included side. So that is known as, what do you think? A, S, A, in the order that it comes. A, then S, then A. So this is going to be ASA. So this is the third shortcut to proving triangles congruent. Instead of all 6 pieces, in each of these 3 shortcuts, we only need 3 out of the 6, so we cut your work in half. So here we go. Select point J on line N. Haven't we done this 3 times now? So point J. Let's go. Seriously, let's go. Make a choice and do it. All right, so we've done that. Construct JK such that JK is congruent to AB. So that's been the same first step each and every time. So we have to measure AB with our compass. So put your brad at A, and then select a hole or a setting that's the same width as AB. So I'm going to select this one. Bring that down to J. Put your brad or your pointy part on J, and then draw your arc mark. And so where it hits the line is going to be K. So we have constructed JK. And we're going to measure from J to K. This one is about 7.2 centimeters, so it's slightly larger than the other ones have been, 7.2 centimeters. Let's see what this one is. Also approximately 7.2 centimeters. Close enough. All right, so we have 2 corresponding congruent sides. Next, construct an angle congruent to angle A using JK as a side. So this is going to be our side. Isn't that the same thing as we did in the last one? So we got to measure our angle. So the first thing that we're going to do is we're going to go up to angle A, and we're going to just create an arc, any length, it doesn't matter what length. This is how you can construct a congruent angle. So any length, I'm going to choose this length. Don't forget that setting. Bring that down and put it on top, put your brad on top of J, or your pointy part on top of J, and make the same arc, but make it big enough. Okay? So that's the same length arc, or distance from it. So I'm going to put a point right here where my arc intersected JK, so I can see it with my compass. We have to measure how far here so we know where to draw our line. So we have to measure this arc from here to here so we get the same angle measurement. So I'm going to put 2 points here so I can read them on my compass. I'm going to put my brad on one of them. I'm going to have to use the inner white part of my compass. So I'm going to choose this setting here. Then I'm going to have to turn it around a little bit, do a little turn, and put my brad on that point that I made on line JK. So here's my brad, but I can't put my finger on the brad because I got to be able to move the white thing. So then I'm going to create an arc that intersects my other blue line. And then X marks the spot. We don't know how long of a line to draw, but we're going to draw a ray from J through the blue X here. And now I've created a congruent angle. So I'm going to measure this angle, which is 30 degrees. And I'm going to measure this angle, which is also 30 degrees. We did pretty well this time. All right, now I did this. Check. Wasn't this, this right here was, oh, we did it backwards. This was our S, but we have to do it backwards for this one. And then this is our A, right? And then we've constructed, now we're going to construct an angle congruent to angle B, so we have to do it over here this time. Same thing as we did here, but it's over here backwards. So I'm going to take a different color. We have to measure angle B. So same thing as we did with angle A, put your grad on B though. You create an arc, however wide you want it. I'm going to make mine this wide. Take that same measurement down to K. Put your grad on K. Don't lose it. If you lose it, go back and remeasure. I'll get a hold of my compass. And then create another arc. Okay. So now I have to measure this arc. I'm going to put a point right here. I'm going to put 2 points here so I can measure it easily with my compass. I'm going to have to use the white part. Here we go. This one. Bring this down to the point that we made on the green line here. And make an arc. X marks the spot. Draw a line through K in your new marker. It's a ray. And then where they intersect is now point L. And if we measure this angle, it is going to be the same as this one. I am running out of time. And then how do they compare? Triangle JKL is congruent to triangle ABC by ASA. Have a good weekend.